Hi everyone, welcome to chapter 6. This is the first section. It's about quadrilaterals. Remember, a quadrilateral is a figure with 4 sides. So we're going to learn about how to classify them, how to put them in categories based on their characteristics and give them names. Is this a square? Is this a rectangle? Is it a trapezoid? Is it just a parallelogram? Is it just a quadrilateral? How do we do that? So that's what today is about. When we describe these quadrilaterals, we're going to use 2 terms, and it's really important that you understand what they are or you will be lost. One of them is consecutive. So we will be describing these shapes as having their consecutive sides, meaning the sides that are touching each other. Those are the consecutive sides. Or their consecutive angles that are right next to each other would be consecutive angles. If I talk about opposites, so opposite sides would be across from each other and would never touch. Same with angles. Opposite angles would be across from each other, directly opposite. Make sure you understand those 2 terms. Our first special type of quadrilateral is a parallelogram. A parallelogram has 2 pairs of opposite parallel sides. 2 pairs. These opposite sides are parallel and these opposite sides are parallel. By definition, that's what makes it a parallelogram. Our next one is a rectangle. A rectangle is actually a special type of parallelogram. If you see this symbol, it means parallelogram. So a rectangle is a parallelogram with 4 right angles. Our next special type of parallelogram is a rhombus. A rhombus is a parallelogram with 4 congruent sides. A square is a rectangle with 4 congruent sides. Or you could say it's a rhombus with 4 congruent angles. So a square is both a rectangle and a rhombus. It's also a regular quadrilateral because all the sides are the same and all the angles are the same. So it's also a special type of parallelogram. Squares have it all. Our next quadrilateral is a kite. A kite is not a type of parallelogram. Opposite sides are not parallel or congruent. But a kite has 2 pairs of consecutive congruent sides. So these 2 sides would be congruent. These 2 sides would be congruent. That makes it a kite. And our last one for today is the trapezoid. Again, not a type of parallelogram. Trapezoids have exactly 1 pair of opposite parallel sides. These 2 are parallel. Exactly 1 pair of parallel sides. That's what makes it a trapezoid. So make sure all those are in your notebooks, especially with their descriptions and how you can recognize them. Hopefully, most of these you totally already know anyway. Okay, if you looked at this figure and you were just asked what kind of subsets or what kind of classification does this look like it has? And you don't have to be necessarily right, but what does it look like it has? And just by looking, it definitely looks like a parallelogram, that both pairs of opposite sides are parallel. And it also could be a rhombus, couldn't it? So you could call this a parallelogram and a rhombus. Here's another one. What does this look like? Well, it definitely looks like a trapezoid. We just have 1 pair of these parallel sides here. So we know that it might be an isosceles trapezoid, which I didn't tell you. An isosceles trapezoid is when the legs are the same length. So it could be isosceles trapezoid. Okay, you are given this diagram and you are asked to find the measures of the sides of this kite. You are told it's a kite, and in the diagram you see KJ is congruent to MJ. So how can you find the lengths of the sides? So look at the fact that it's a kite tells you these, and the fact that these 2 are congruent means x plus 5 has to be exactly the same length as 3x minus 1. You use that relationship to set up your equation. You say x plus 5 equals 3x minus 1, and then you solve for x. So I did that. I said x plus 5 is equal to 3x minus 1, and I solved for x and realized x equals 3. But remember, the question asked me for the lengths of the sides. So once I have that, I plug that in. If x is 3, then this side is 3 plus 5, or 8. And this side is 3 times 3 minus 1, or 8. Sure enough, those two are congruent. Because it's a kite, I can do the exact same thing with the other two sides, set them equal to each other, because by definition, a kite has congruent consecutive sides. So 3 times y plus 2 is equal to 5y plus 2. I set up my equation and I solve. When I solve, I find that y equals 2, so I'm going to do the same thing I did with the two shorter sides. I'm going to plug in 2 for y in these two sides and see what their lengths are. If y is 2, then 5 times 2 plus 2, this side is 12, and this should be 12 as well. 2 plus 2 is 4, and 3 times 4 is 12. So sure enough, I found the lengths of all four sides. Okay, here's an example of another problem. Now I have a quadrilateral on a coordinate plane, and I'm asked for the most specific classification I can give. So it looks like a parallelogram. It could be a rhombus, could be a square. I'm not 100% sure. So what I'm going to do is I'm going to check. So let's look at, first of all, let's just make sure it's a parallelogram. Let's check the slopes of opposite sides and see if they are the same. For instance, from R to S, I would go up 3 and over 2. So its slope is 3 over 2. And this side is up 3 over 2. It's also 3 over 2. This slope is up 2 to the left 3, so it's negative 2 over 3, and up 2 to the negative 2 over 3 again. So I have just discovered opposite sides are parallel, and these slopes are perpendicular. At least this is a rectangle, because I've just established, since these slopes are perpendicular, that these are 4 right angles. So now all I have to do is determine, is it a rectangle or is it a square? And I don't have to find the lengths of all 4 sides, just 2 consecutive sides will be enough. So let's start with using the distance formula in RS. The difference between my x's is 2, so that's going to be 2 squared, plus the difference between my y's is 3, so that's plus 3 squared, and that, I'm just going to leave it like that. Now I'm going to do the same thing with RU. The difference between my x's, between here and here, is 1, 2, 3, so that's 3 squared, plus the difference between my two y's is 2, so that's 2 squared. Are those the same? The square root of 3 squared plus 2 squared, they look the same. So the most precise classification for this quadrilateral is a square, because opposite sides are parallel, they are consecutive sides are perpendicular and equal in length. This is a square. We know that if we add up the angles in a triangle, they always add up to be 180 degrees. We've already established that. What if it is a quadrilateral? What do their angles add up to be, and how do we know that they add up to be that? So I'm going to look at, I just drew a quadrilateral up here, and what I'm going to do is, since I know that triangles are 180 degrees, I'm going to see how many triangles I can make in this quadrilateral from one vertex. So if I draw a line from here to here, I realize I can make 2 triangles. 2 triangles. Each triangle is 180 degrees, right? So I have 2 180s, or 360 degrees. It doesn't matter what shape my quadrilateral is. It doesn't matter if it's a kite, a trapezoid, a parallelogram, or just some random quadrilateral that doesn't fit any of those categories. All four angles will always add up to be 360 degrees. What if I have a five-sided figure? How many degrees would those angles add up to be? Let's do the same thing. Let's pick one vertex and see how many triangles I can make. So I'll pick this one, and I can go this diagonal and this diagonal. Those are called diagonals. And I made 3 triangles. So 3 triangles. Each triangle is 180, right? So that's 3 180s. That is 540 degrees. I wonder if that will work if my figure has 6 sides. Let's try it with this 6-sided figure. So I'll do the same thing. I will see how many triangles I can make. And it looks like I can make 1, 2, 3, 4 triangles. So 4 triangles or 4 180s. That 4 times 180, that's 720. And sure enough, all of the interior angles of a hexagon or of any 6-sided figure will always add up to be 720 degrees. Do you see a pattern? Notice in my 4-sided figure, I was able to make 2 triangles. In my 5-sided figure, I was able to make 3 triangles. In my 6-sided figure, I was able to make 4 triangles. So notice the number of triangles was always 2 less than the number of sides. So this is what you do. When you have a polygon of any number of sides, you take the number of sides and you subtract 2 from that. So I'll just take n minus 2 for the number of sides, subtract 2. That's how many triangles you can make. So I'm going to multiply that times 180, and that will be what the interior angles of your polygon would add up to be every single time. Every single time. So reliable. So reliable. It's because God made it. So of course it's reliable and we can count on it. So that formula that I just showed you is called the polygon angle sum theorem. The number of sides, take 2 from the number of sides, multiply that by 180, and you know what the sum of all the interior angles will be. Out of all the interior angles, it would be that number. Now, if it is a regular polygon, like a regular hexagon, which means that all of these angles are congruent. Just by definition, that's what regular means. And you are asked, what is the measure of each individual angle if it's regular? Then what you would do is you would take the number of sides, subtract 2, multiply by 180. Here we got 720, right? And then you would take that and you would divide that by the number of sides, which is also the number of angles. 6-sided figure has 6 angles. 5-sided figure has 5 angles. 4-sided figure has 4 angles, etc., etc. So by whatever that number is, you divide it by that. So in this case, it would be 720 divided by 6. That gives you the measure of the interior angle. So we just figured out that the measure of an angle, interior angle in a regular hexagon is 120 degrees. Let's do the same thing with an octagon. So an octagon has 8 sides. So to figure out the sum of all its interior angles, I would take 8 and I would subtract 2 from that and multiply that times 180. So 6 times 180. I believe that's 1080. Then I would take that total, 1080, and divide it by the number of sides, or by 8, and I would get 135. So each angle has a measure of 135 degrees. So earlier when we were working with triangles, we extended one side of the triangle and formed an exterior angle and talked about some of its properties. So I have a triangle, a quadrilateral, and a pentagon, five-sided figure here. And I have extended all three sides to show all the exterior angles. There's one exterior angle at each vertex. It's not this angle here because that would be congruent with the congruent with the interior one, right? But it's this angle here. So if I wanted to take those exterior angles and add them up, what would they be? What would they be if it is a three-sided figure, if it's a four-sided figure, if it's a five-sided figure? And now it sounds like we're getting really, really complicated. But exterior angles are really easy, and I'm going to show you why. Because if I take each one of these figures, no matter how many sides it has, and it doesn't matter if the sides are congruent or not either. It doesn't matter if it's a regular triangle or if it's just a crazy one. It doesn't matter. Any figure, I can always draw a circle around it. Right? And I can draw a circle around this. And I can draw a circle around this. And if I extend those sides in these angles, do you see how this angle encompasses all of that, all the circle? Same thing here, this angle, between this angle and this angle and this angle and this angle. I've covered the entire circle. Same thing here, between this angle and this angle, and this angle, and this angle. I've covered all of the circle. Why do I care? Because how many degrees are in a circle? 360. So it doesn't matter how many sides are in my polygon. The sum, the total of the exterior angles will always be 360 degrees. It's just a given. Thinking of the circle that goes around it is a great way to help you to remember that. But there is the theorem there in your book to put that down to remember, because you'll forget on a quiz or a test. So this is handy to have in your notebook, that the exterior angles of any n-gon, any number of sides, always equals 360 degrees. So I'm going to end the video here. I'm not going to give us a lot of practice problems to try to go through this. Just remember what the names of the different quadrilaterals are and how to find the sum of the interior angles by making triangles. The number of triangles is always 2 less than the number of sides. And also how to figure out the sum of the exterior angles, which is always a circle, which is always 360 degrees. And make sure also that the characteristics of your different polygons are in your book. You know, what makes a parallelogram, what makes a rhombus, what makes a kite, etc., etc. And that's it for now. I will see you guys in the next section.